It's a rainy day. I don't know if it's a rainy day for you, but definitely a rainy day for me. Here in New York, we've got that tropical storm action coming at us. I don't know too much about it, but it seems a bit apocalyptic. Not gonna lie. But, you know, there's rain, there's wind. The trees are kind of waving. It's exciting. It's exciting. I'm pretty excited for the stream today. We're gonna be taking a different tack. We've been doing this exec gen stuff for quite a long time, which has been about improving the code generation for the SQL engine, right? So we're gonna do something a little bit different today. Yo, Arjun, what's up? Our Lord returned, Search. How you doing? I like that. Raise your dongers guy, if that's who he is. But yeah, so I'm pretty psyched though, because you know there's this project that I've been thinking about for a really long time. We have this explain mode that tells you how your query is distributed, right? CockroachDB, distributed database. It's all about the distribution of the plans, right? You run a SQL query and you want to distribute it to all the nodes in the cluster, or all the relevant nodes anyway. And the way that we display this stuff, it's a bit, I mean, it's cool. It's graphical. It shows a graph on a screen, and I'm going to show this all to you all in a bit. But it gets a bit crowded if there's like, you know, 20 nodes in the graph, or if it's a big old query, complicated, lots of edges. It gets a bit unwieldy. And so what I've wanted to do for a while is prototype what it would look like to have sort of a more traditional text-based explain mode for these distributed queries, so that people can copy paste them, send them around, you know, in a little bit more of an easy way. We'll see. I think there's pros and cons. Like sometimes you sort of want that graphical, sometimes you want that text, but I'm gonna play around with it, see what it looks like. I think it should be pretty fun. So I think what I wanted to start with before we get too much into the depths, you know, is just a quick little mini demo to even also just remind myself of what we're working with, because to be honest, I've been touching this exec gen stuff so much that I haven't really played around with the distributed plan viewer in quite some time. So I'm gonna play with it. That's gonna be the first step, get a query that is distributed to look at, and then we can start thinking about how we would want to change.
Everybody knows that relational databases.
Arjun, thank you so much for that Twitch Prime subscription. I really appreciate that. Enjoy your emote. You've got one emote to use. Welcome to the club. Welcome to the large data bankers, as one of our viewers likes to say. But thank you so much. I really appreciate that. But yeah, so we're gonna try to do this little demo. And I think that this Cockroach demo guy has a facility for this. I haven't used it in a little bit, but I think if you pass, so this is just, you know, your database binary you're maybe used to. If you run Cockroach demo and you pass in a nodes argument, it's gonna actually spin up a couple of in-memory nodes for you to touch and play with. Easier than having to set up a whole actual cluster with multiple binaries running and stuff. It's not that hard to do that, but this is a bit easier. So what I think I want to try to do is try to simulate, well, let's make a database first of all. We'll call it foo. We like to use the word foo, because why not? And we're gonna make a database, make a table rather, that's just, it's got a bunch of data and it's scattered around to a couple of different ranges, so that we can sort of simulate what it would look like to have a query touching multiple nodes in the database, since that's the whole point. So we'll make a table. We'll just call it, Somebody actually told me I should use better examples. I shouldn't use I shouldn't use foo. I should make a users table. So I'm gonna try that out. Create table users. They're gonna have an ID. It'll be an int, or should it be a? Arjun wants TPCC. Nah. I guess I could. Should I do that? Nah, it's too hard. Too much of a pain. I'm not doing TPCC, but honestly, that's such a good idea. You've brainwormed me. I'm gonna try this for now. Okay, so I'm just gonna make an ID int primary key, and I'm gonna give these people names, and that's just it. All right, we'll just keep it nice and simple. TPCC is a cool idea. Maybe we'll get there. Maybe we'll get there later. I'm gonna insert some data into the table. Yeah, I think you're right. I think you're right. I think you're right. It's a useful mental model. It's a good one to have in mind. Think about those warehouses. Just have like a schema in your head, right? Or mover. That's why we like this sort of sample database about people's cars and stuff like that, kind of an Uber clone, but I just don't know. I don't know. I like to keep it simple sometimes. I got to practice off stream. So we'll do insert it to users, select G, and we'll give them all the name. We'll give them all the name Arjun. So we're gonna just make a bunch of integers like so. And we have to also call it something. This is gonna give me a table with a bunch of users. They all have different IDs and they all are named Arjun for some reason. All right. And so what I want to do, so I just want to start here, right? So if I run explain dist-SQL, this is the way to get that distributed plan in CockroachDB. If I run explain dist-SQL, we'll do select count star from users, right? And then I open up this URL. What I get is this little graph. And you can already see that there's something going on here because we've got two boxes. We've got a node 1 box. We've got a node 3 box. And that's kind of cool. But I was really hoping to get something a little bit better with a few nodes going on so you can sort of see the problems with this. And to be honest, it's going to be a bit hard for me to make a query on the fly that's got problems. Probably to show you a query with problems, I'll use some of our test cases because we've got quite a few sort of problem test cases. In the test cases area, also my keyboard cam's a bit out of whack. I got to give you those hot cherry MX whatevers, give you that good feels in the brain pan. Okay, so cool. Right. The other thing I wanted to show you is like what happens if there's data for this table on multiple nodes. That's kind of the crux of it, right? Right now it sort of seems like maybe we're talking to this node. There's some no-op thing. I don't know what that is about. And then all of the data for the users table is living on this node here. You can see node 3. I don't know if that's big enough. I'll make it a bit bigger. So what happens if I force some data for the users table to live on different nodes? What does the graph look like for that? So in order to do that, I think the way to do it, there's this scatter thing. So I think it's like alter table users. No, first I have to split the table, right? So it's kind of like, hold on. If I say show ranges from table users, I think what this gives me is all of the different ranges that the table split up into. And a range in CockroachDB is kind of like a shard. The system handles it, but it's kind of like a chunk of data from a table. And you can see that there's only one range in this table. So I sort of want to make sure that there's a couple ranges in this table so I can show this off. So what I'm going to do is I'm going to split the table manually. Alter table users split at. And then I think what this is going to be is a list of spots, primary keys, since we're talking about a table with a primary key, that we should split the table at. So maybe I think I put 10,000, 100,000 values into this table. So what if I split at 50,000? You can't put a comma. That makes no sense. Gosh, what am I doing? Okay, so I've got another range. Now I think if I do show ranges again, what I'm going to see is that the table's got two different ranges, which is great. That's sort of the dream. There's a bunch of information here. There's a start key and an end key. So it's sort of like what are the values that the range encompasses for each of these ranges of the table. There's sort of like some size estimate for the table, for the range rather. There's a leaseholder, which is very important. There's replicas. So in my cluster, my little sample cluster, there's just 3 nodes. So it makes sense that there's just 3 replicas. Sorry, that not quite what I meant to say. There are just 3 nodes, and there's also replication factor 3 by default for everything. So everything is living on all the 3 nodes. But the leaseholder is the same for each of these ranges, which is sort of why this explain plan is a little bit boring still. If we look at it again, we should hopefully see that it is in fact still boring. In other words, like we see all of the data coming from node 3, since even though there's a couple of ranges on this thing, we know that we can read those ranges from this table. Because in CockroachDB, by the way, in order to read data from a range, you have to pick the leaseholder of that range, which is sort of like the leader instance of a particular range, and it can live on different nodes. So what I want to do is make sure that these two ranges that I've made up are split up on different leaseholders. And I think that there's a way to do this like precisely, but since I don't really care, I'm going to use this thing that we have called alter table scatter, alter table users scatter. And what this is supposed to do, and I've had medium amounts of luck with this, I would say, but what it's supposed to do is randomly decide for each of the ranges in a table which leaseholder owns that range. So if I do show ranges again, hopefully I'll see that the leaseholder is on different nodes. And that is in fact what I see in this case. Now the first range is on leaseholder 2, and the second leaseholder is on range 1. Or excuse me, on node 2 and node 1. All right, so now if I go back and I run explain to SQL again, hopefully I will see something different. And I do. So this is cool. What I'm seeing is that the database automatically knows to distribute the scan for this query to each of the nodes that own the particular range that lives on that node. So why do we do this? The reason is that in this particular query, we're counting. We're just doing a count star. We're not doing any processing. We're not streaming the rows back. We don't actually even care what's inside any of the rows on this table. All we care about is the count of them. So what we can do inside of the database in the optimizer, well, sort of phase of the optimizer, is that we can decide that, hey, we can actually do that counting completely local to the node that owns the data range in question. And since this table has two ranges, we can split up this responsibility and push down those counts to the nodes that own that data. So what's happening here is that on node 2, which owns the first half of the table, we're asking node 2 to be the one that counts up all those rows and sends back, instead of all the rows to the gateway node, to the node that we connected to and asked for the query from, just the count. So obviously it's going to be a lot more efficient if you don't have to send all 50,000 rows. You're only sending that count, that single number. And it's the same with node 1. In this case, it happens to be that the node that is running the query, so what we call the gateway node, where this kind of response is sitting, it just so happens that that node also owns the latter half of the table. So this table reader here is what we call a scan. So it doesn't have to send anything over the network, but in any case, you can imagine that if there was 3 nodes involved, or 5 nodes, or 20 nodes, we're always going to push that counting down close to that that read. So that's all good and fine. And this is quite a cool thing, I think. But the truth is that for one of these more complicated queries, maybe I should show you an example of that now. This graph, which is really quite nice now, this is very appealing. It's like, okay, you can immediately see what's going on. There's a couple nodes, there's some lines where the data is transferring and stuff like that. The processors are taking multiple inputs and stuff like that. It's kind of obvious what's going on, at least to me, since I've been staring at these for a long time. But once it gets complicated, and I'm gonna show you an example of something that's complicated, making sure not to close my database window since it's all just in memory and it'll all just go away completely. Let me quickly just show you an example. How would I do that? So maybe I'll just search for explain this SQL in our tests. Maybe it needs a space. So let's say, I don't know. Let's say maybe one of these guys in here. So let's look at this test file here. This is where we save a bunch of plans to make sure that they're kind of as we expect. It's the way that we test these things. So for example, this thing, I mean, you guys, if you're watching, if you're listening, tell me what you think about this plan. I think that this plan is already on the way to becoming unreadable, if it's not already unreadable. Arjun says it's a work of art. And it's nice because it's all symmetrical, right? You can sort of see like that every node is talking to every other node. A true Jackson Pollock. Yeah, you know, so like, I don't even, what's going on here is we read some data from some table, we sort it local to every node, and then we redistribute by hash each of the rows in that table into a joiner. And we do this because the joiner expects sorted inputs. But the thing is that like, and you can sort of tell like, since everything's looking so symmetrical, that like each of these distributions is just sending to every other node. But you can imagine that there's plans that are not as symmetrical, not as easy to read. The full bisection edges. I guess what you mean by that is the edges that just the ones that go across the entire screen. Yeah, well, I agree with that. I think the edges are bad. The other truth is that this example doesn't really show it, but in queries with lots of columns, these things also tend to become completely unreadable because each of the boxes, they start to fill up with huge amounts of text. And then like the whole thing is like on multiple screens, you have to be scrolling, and it's just like a total nightmare. Is that Graphiz? Yeah, this is Graphiz. What's up, N Selecki? How's it going? Nice to see you. I think what this is doing, I think it's like a JavaScript Graphiz viewer. The way that this works in the database is that we ship a bit of like, you know, base 64 encoded text to this front end thing. And then the front end is just totally stateless. It just decodes this and then passes it to some JavaScript Graphiz viewer thing and prints out this like boingy graph, which is super cool. You know, it's cool, but it's unreadable. That's the whole point, right? It's like, why it's force directed. Congratulations. You know, you can like drag these things around and it's super fun. You can watch them, but like, why does anybody really care about this, huh? Except that it's super fun. I like it. You know, when I look at these things, I often just like mess around a little bit. Just like this table reader, it's like, why is it stuck under this table reader? Can I like scoot it out? Speed run for how quickly you can sort the table readers with the mouse. Exactly. Eternal problem with graph is when you get so many edges. I completely agree with you. For a non-DB nerd, it seems cool, but not that useful. Got to play a little mini game to get it perfectly symmetrical. Yeah, exactly. So, I mean, I don't know. Obviously, this is not going to be like super trivial to fix. Yo, MD Layer, what's up? Happy Friday to you too. I hope you're doing good. I hope it's not storming where you are. Well, I don't know. I mean, storms are good, but it's getting intense here, you guys. I left a window open and water just came all up in my house. Just not really what you want. I do have one emote, yeah. You don't like that large G2 agent? What's up, Spartan GTR? What's up? All right. So here's the plan, you guys. Here's the plan. On the other hand, right? I like that emote, to be honest. Okay, so here's the other plan. Here's the plan. Instead of making it so that every time you have to investigate this distributed plan, you have to go to this URL and check out this, you know, GraphViz thing, which can be cool, can be uncool, depends. What we're gonna do is try to make something that's more akin to what happens if you don't put that dist-SQL modifier. So if you go like this is closer to what a sort of, you know, I would say traditional explain plan looks like in databases. This is showing you, without regard to distribution, the operators that the query is using. So it's doing a scan of a table with some spans or whatever, full scan. You know, we're not doing any filtering low level where the database can make it efficient. That's what this means. And we're doing a group by, you can see because of this group node. With some attributes, you know, this is basically telling you like what these operators are. But the goal of this stream is that I want to make something that looks a little bit more like this rather than this. And we'll see how far I can get. There's one other, yeah, so there's another variant. There's like several variants. That's one of the problems of this database, I think, is that we've had like quite a bit of a proliferation of explained versions kind of problem. Because there are just so many different ways to visualize this information. And, you know, it's a graph. It's sort of like candy for DB developers, I think, to try to develop a new explain mode. So I guess I'm probably falling prey to this candy a little bit right now. You know, we've got explain opt. This is going to show you like the optimizer specific representation. You can like stick a verbose flag on this thing, which gives you way more information, including costs and stats and functional dependencies and all sorts of crazy stuff. You can ask for an explain vec plan, which is showing you, so this is, I did actually want to address this because explain vec is showing you what the plan would look like if you used the vectorized SQL engine, which is what a lot of the things that we've been doing on the stream before this one, sort of the implementation of some of these operators. But the thing is that the vectorized plan explain is actually distribution aware, as you can see. There is a little bit of information here. There's node 1, you can see there's node 2. You can see that there's like maybe, you know, it's also kind of funny is that compared to this distributed plan where you read it top to bottom, You know, you go to the top of this distributed plan, you see that there's a read, then you go to a sort, then you go to by hash. Everything else on the command line is actually inverted, which always gets me super confused. So you start from the bottom or from the inside and you go out. You're starting with the scan and you're going up to group or out to group. And it's the same with this one. So I was just lost for a second. But you can see what's happening here is that on the first node, we're doing a scan, we're counting. We have a synchronizer, which is what this node over here is. This ordered blue box thing is taking multiple streams and synchronizing them into a single stream. So you can see that that's happening here. There's an inbox, which is saying this is a network stream. I'm getting something from another node, which is connected to this outbox, which you can't see, by the way. So we've made a decision to not draw that edge like we do all these edges here. We just don't draw the edge here. And you know, it's for better or for worse, I'm not sure. And then it goes all the way to the top. You see there's some distincts, there's some aggregations, whatever. Distributed data is so hard. Purposely stay away from that stuff unless you count BGP, the OG distributed database. Yeah, you guys, this is like the network nerds join database nerds contingent of Twitch, I want to say. MD Layer's stream. Also shout out to MD Layer with this SO tool that I added. Check out his stream. He does networking stuff. It's cool. Only database I trust is Route53. Absolutely. All right. So basically, what I'm hoping to do is get something that kind of looks like this, except not as complicated. We don't want all this detail, distinct chain ops. Like this is sort of more for debugging information for people who work on the vectorized engine in the first place. Like I don't really expect people to know or care what this is who don't work on the database. But I sort of want to combine this distributed plan on the command line with this, make it nice. All right, okay, we got it. That's enough. That's enough information. I think we should just go ahead and dive into things. Give it a try, see what happens. Right? Is there one other thing that I wanted to do first? I think there's one other thing that I wanted to do first, which was that, okay, so over here, remember I showed you this complicated plan and how it looked on the front end. What I sort of wanted to do is make it so that you could see that plan with explain vec. So that, well, you know, maybe I don't actually care to do this right now. I'm gonna say I don't really care to do this. Okay, so we'll just go ahead and get started. It's gonna be fun. It might be a disaster because I didn't really plan anything for this stream besides just like vaguely wanting to do this, and then somebody encouraged me, so I decided to bump it up in the priority list. So we'll just have to see. Okay, so basically, here's what's up. Here's what's up. The way that any of these explain things work is that they take in as input this data structure called a set of flows. Oh no, my project is out of date. Okay, hold on. Hold on. Project edit. No, wait. Commands edit project updating, or let's say prototyping a text-based distributed explain for CockroachDB SQL. How about that? You started your stream a couple weeks ago by trying out an idea that ended up being a total waste of an hour, so don't feel bad it happens. Oh, I don't know. Nothing's really a waste, is it? Nothing's a waste. If you're learning, if you're having fun. I feel like last stream I was depressed, but I got something working in the end, but I was really depressed because the thing I was working on was just horrible. So it was like sad, sad, sad. And then at the end I was like, okay, I guess I'm happy, and then I quit. All right, so anyway, so here's the thing. Here's the thing. This is the data structure we care about. There's this thing called generate flow specs, which gives you back a map from node ID to a protobuf. A protobuf. And the protobuf has a flow ID and it's got some processors, and the processors are those things in the boxes, right? These are the boxes. A flow is roughly like this thing, I want to say, more or less. I mean, there's some subtlety to it, but roughly it's like all of the boxes that I'm highlighting with this little tool. It gives you this map, and then what you can do to get an output is, well, you process it. You come up with some way of representing it. Last stream was depressing. It was depressing because you were depressed about being depressed about the project. Yeah, you're right. I mean, I think I was also tired. I think I'm learning some lessons, which is that you shouldn't stream when you're tired. You shouldn't stream if you're depressed about a project, because it's just not that fun for the viewers, probably. Yeah, meta depression. Not great. Not great. I'm feeling a lot of energy today, though. So hopefully that won't happen, you know? Hopefully that won't happen. Right. Okay, so here's the other thing. If I go to this file, explain vec, what this does, this is an alternate way of processing those flows. And it's very simple. And the simplicity of this thing, this is what got me sort of motivated to do this project in the first place. Because truthfully, this is just such a simple algorithm. What we do, we get these flows, we do a little bit of pre-processing, we sort the flows for reasons, and then we use this convenient abstraction that somebody else built called a tree printer that allows you to assemble these really nicely formatted text trees. And all we do is really just traverse this flow, or each of these flows with recursion. Okay, maybe it wasn't that simple, but for each of the flows, right, we create op chains, which is not necessary for this thing that I'm doing right now. It's just because that's how the vectorized thing works. You have to like post-process the protobufs essentially to make another thing. But the point is that once we get these op chains, we call a recursive algorithm called format op chain, which calls this do format op chain thing, and it is going to build a tree. And the tree is implicit, right, because of the recursion. We're just following the tree that's already given to us by the input data, and we're calling these APIs on this tree printer thing that kind of prints the tree, since we're recursing through it, right? Every time we go down a level, we say, tree, give me a new level in the text output, and it'll print it. So I don't know. I don't know if that was totally straightforward. I feel like I bungled the explanation a little bit, but the point is that you do get this sort of elegant recursion that doesn't make it that complicated. And I think the complication is just going to come out, what do we actually print out inside of that tree? So the first step that I want to do is get sort of this simple recursion going for the protobuf representation, which is what we have before we pass it to vectorized. Okay, let's take a breath. Let's take a breath. I think what I'm going to do is I'm going to make a new variant. I'm going to call it, well, do I want to do that, or do I just want to put it inside of explain to SQL so I don't have to do anything more? I just don't want to get into like a war about what's the future of explain to SQL. I'm not exactly sure. Auto vectorization. Dude, that's like a whole other topic. That's a whole other topic. The Rust heads in this channel are going to be like, dude, why didn't you use Rust for this project? Why didn't you use Rust for this project, Jordan? They have auto vectorization. And I'm going to say it's not my fault. I have no choice. I'm stuck with Go. GG. No re. Okay, so let's just, I think we're going to stick with this explain to SQL file just because I think it's going to be a bit easier. All right. Okay. So this is the point in the program where we have flows. And what we're going to do is we're going to process these flows. Maybe I should make a little library. Maybe that would be the first thing to do. If the input is these flows, the output is this text diagram. Something like that. Auto vectorized container vector someday. Yeah, it's possible. Dude, and by the way, hold on a second. Let me just take a brief pause, talk to the camera for a second. So I know I was talking about writing this blog post, right? About the vectorized engine and why we need execgen and everything like that. The truth is that sent me down an enormous rabbit hole of thinking about how we might actually secretly not need execgen if we carefully set up all of our data structures and trust the inliner. That's why I built that GC assert thing, by the way. It's because I wanted to make sure that I could figure out if the compiler was actually inlining calls. So it's like, I'm now trapped between two worlds and it's awful and I don't even know what to do, but that's why I haven't written that blog post. GG. So let's see. Let's make a package. Should we make a package? Let's make an explain package. Why don't we have an explain package, dude? This is crazy, I'm just realizing. Let's make an explain package. Okay, so we're gonna say make dir package SQL explain. Should have done this a long time ago. The first file in this package is going to be called, it's gonna be called dist. It's gonna be called dist. And what it's going to do is that we're going to have a func called right. Whoa. NC Lucky, just like to interject for a moment. What I'm referring to as Rust is in fact Rust LLVM, or has recently taken to an LLVM frontend for a language named Rust. Rust is not a programming language unto itself, but rather another free component of a fully functioning compiler system made useful by the LLVM IR optimizer shell utilities and vital standard library components comprising a full programming language. My mind has been blown.
Computer's hooked into over 1,000
Yo,
data banks throughout the world.
Malakianair. Thank you. Malakianer. Thank you so much for the follow. Dude, I don't even know what to say. I'm sorry if I've offended you. I think LLVM is epic. I don't. Is that a good enough summary? Rust is basically utilizing LLVM. Is what I hear you saying. I could believe it. It's a Stallman meme. Oh my god, dude! I just got trolled by a copy pasta bot. You need to like. I don't even know. I don't even know. I need like a reaction GIF for this or something like that. I'm rendered speechless. This is a sad moment in my stream. Yes. Yes. Oh man. Have you guys ever seen? Look. I'm not going to turn this into a Stallman bashing stream because I respect Richard Stallman. But have you guys seen Richard Stallman speak? I have. It was quite an experience. That's all I'll say. All right. Okay. So here's the thing. We're gonna write a function. We're gonna call it write explain dist SQL text or something. Write distributed explain. It's gonna take in flows. It's gonna take in, what is flows anyway? It's this map thing. I guess it could take in a physical plan. How about that? Then I guess it has to import physical plan. Does this thing import physical plan? This is just like some protos. I think I'm gonna take it, just make it take this map. That seems easier. Maybe we should make an abstraction around this map later, but we don't have to do it for now. Yeah, so I don't know, watching Stallman speak, it was quite fascinating because the truth is that, like, I don't know if you guys, you know, people talk about how, there was this anecdote going around Hacker News the other day about how Bezos was like a consummate salesman or something like that. He was like, the guy on Hacker News was like, it was my first day at Amazon or something. I sat down at this big dinner for all the new hires, and Bezos came over and like talked about why Amazon was such a great place to work or something like that. Uh-oh. Little blip in the stream there for a second. I hope it comes back. But anyway, so he gave his pitch. He left the table, and then at the end of the dinner, the guy heard Bezos giving the exact same pitch, you know, sentence for sentence or something like that, to some of the other tables. And the point was just that, like, yo, to be a CEO, you got to be a salesman. And being a salesman, repeating something over and over and over again, that's how to make a vision. And to Stallman's credit, right, that's what he does. That's this power. This speech that he gave, I mean, it was like to the T, all of the points that you know about
Computer's
Stallman.
hooked into over 1,000 data banks throughout the world.
Yo, 19 letters long. Thank you so much for the follow. And yeah, you know, he's idiosyncratic. He's a funny guy, but he really hits all those free software points. It's awesome. You know, it's awesome. Anyway, now that I'm up on this meme, let's do this, huh? So this is gonna take in a set of flows. I think it'll also take in like a writer or something, like a I don't know, io.writer or something like that. Isn't it? Is it not called io.writer? It has to have a variable name. There's my problem. Okay, so it's gonna return an error. And I think what I'm gonna do to start off is just copy and paste this little iteration loop that we've got in explain vec, because I don't really remember the setup that we did for that, and I don't really wanna have to redo it. I guess we just sort of sort it and set up a tree printer, set up a root. I'm gonna grab that stuff. We also have this flow with node thing. Oh, so we could sort it. Okay, I'll grab that too. There's a little prior art, right? There's a little prior art. What is the point of this flow with node business? I don't really know. It's just so we can... Oh yeah, it's right. It's just like a sort container. Haha. Sort containers. Okay, so let's also make a quick doc string for this. So write distributed explain takes in a map from node ID to flow spec and writes a textual distributed plan. Yo, Lithium, what's up? Is it you? Is it you? Could it be possibly you? Congratulations, that's an exciting step. How's it going so far? You're not a fan of copyleft? I don't know. Textual distributed plan to the given io.writer, returning an error. Well, we don't need to say that. Everybody knows that things can return an error,
Computers
right?
hooked into over 1,000 data banks throughout the world.
Yo, user undefined, thank you so much for the follow. How did I guess it? I don't know. I just had a feeling. I can't explain it. Okay. So it's gonna sort the flows. It's gonna, we're gonna start out this tree printer thing. So what, hold on a minute. I don't actually really remember the API to this thing, this tree printer, which is a very cool piece of library. I feel like this should be open source because, I mean, it's not open source. What I mean to say is it should be moved into its own library because, man, I could really use this thing in more places than just a database. So new with indent creates a tree printer like new, printing customization, left pad controls whether the, oh, okay. So I guess this is kind of just like a way of changing the visual output that this tree thing gives you. Okay, so here's the instructions, right? So we make a new tree printer, we get a root, and then if you call child on a node, what it does is that it prints a line out and gives you back a new node. And you can keep calling child on that to get an even new node. In order to put text, I see. I guess it's sort of like in order to put text, what you actually do is just make the child's name have new lines inside. Is that really like the whole API? I'm pretty sure that guy followed you for the double underscore alone. Yeah, you're right. User undefined. Hey, user undefined, you and me were buddies. We got that double underscore life, living that life of double underscore names. Drop one of those old XDs. We love those XDs. Yeah, I guess so. I guess. And you can child F, which is nice. So you can pass a format string without having to add line. Ah, so you can also add line. Okay, so I think this is the way to do it. You can do child with a new line, or you can say add line on a given node, and it's going to give you a new bit of text. MD layer new handles with. That's awesome. My Twitch name is basically a meme. That because I didn't really think I was going to do this every week. I was kind of making a joke, but I sort of like it. I don't know. I like the double underscores. MC layer. All right. So here's the thing. What do we have, right? So it's like for node ID flow in range flows. Let's actually make something happen here. What is a flow? A flow has an ID, it's got some processors, and these things I think are just totally unsorted, right? That's a little bit unfortunate. We'll probably have to pre-process these quite a bit, actually, to make this work at all. We sort of need a graph, and what they give us is just a flat set of things with an implicit graph, no pointers, right? It's like a swizzled graph or whatever you want to call it. So I think the way it works is that input. Get rid of this split window because I know you guys can't see over there. An input sync spec has a set of streams, and each of the streams has a stream ID. And I think the idea is that you link up the stream ID in your stream endpoint spec with a stream ID in an output router spec, right? So here's our output for each processor. There's a set of outputs, and each output has a stream ID inside. So I think what we have to do is we have to build a graph using these stream IDs, which I don't know, it's not so bad. We could just make some maps and stuff like that. Dude, yeah. XXX sniper, man, that's the way to do it. That's like the ultimate name. Okay, so let's build a little graph. I feel like we've probably done this exact same graph build like 5 times throughout the code, but you know, whatever. It's not such a big deal. Maybe we'll do another pre-processing step. So we'll say for I processor in range flow.processors. And I think we also need a for j input stream in range processor dot input input stream dot. Oh my God, there's so many. There's like a lot of nesting here, you guys. 4K. I guess this is actually input. Oh, right. So in most cases, there's just one input. I don't know. We'll get here later. This is actually not input stream, but input. Input stream in range input dot streams. You know, actually, here's the thing, you guys. You know how like in AIM, you can put those. Everybody was all about their user profiles in AIM, right? People would like put like funny quotes from their friends and stuff like that. Here's the thing. GitHub had the brilliant idea to make an about page for every GitHub username. So you can go wild. You can put your friend's quotes in your GitHub profile pic, and it's like, I don't know, it feels super like old school for me. Like check out what I've done. I haven't done much yet, but look at this, dude. Look at this. You got the computer thumb GIF right on my homepage. It's still kind of hidden. Yeah, it's a little hidden, but like you just make a repo with the same name as your username, and then it automatically does this. Anyway, I'm a fan of this whole thing. Well, I want to make something better, but for now, that'll do. Once I get beyond 2 loops or need defers, I factor out the loop body. Yeah, I'm probably going to do that. I'm like roughing something out because I don't even know what I'm doing in these loops right now. I'm just like messing around right now. So we have a stream ID, and I think what we want to do is sort of build a map. We're going to say, let's see. So we'll say stream map. We'll say input stream map equals make map from stream. And what are we really trying to do here? It's really like we want to map from the stream ID. What is a stream ID again? It's a exec infra pb.stream ID. Exec. Yeah, exactly. MySpace. We just need like music. If you can embed some music play on your GitHub page, that's really going to be the next level thing to do here. Okay, so we're going to make a map from stream ID to what exactly, right? That's sort of the question. What do we want to be showing? Over here, what we're showing is that for every input, this is an input, this blue thing, we need to know all of the outputs that's hooked up to the input so that we can follow the link, I guess. So I think it's really like a map from stream ID to processor spec. I think that's what it is. So I'll put a map from stream ID to whatever this thing is, which is a exec infra pb dot processor spec. Now, there's like a little bit of a problem, which is that this guy is gonna get copied, you know, and that's like not cool. So maybe I'll just make it a pointer to processor spec. How are these multi-input, multi-output nodes gonna look like? So the stream's on a heavy delay. Do you know how to fix that? I have no idea how to fix that. Brohanster, so check this out. So you know how explain vec works? With explain vec, you can have multiple outputs looking like this. You just don't show the links. It's maybe a hack, right? But like, for example, this inbox here connects to this outbox, and you can't tell because I haven't put any kind of IDs there. But you could imagine putting an ID next to the outbox that's the same as the ID that's next to the inbox, so that people can visually see how things connect up. I don't know. I mean, that's one idea. You need to refresh. I don't know. The stream delay stuff is really confusing to me, to be perfectly honest. I don't know how it works. All right, so here's what we're gonna do.
Computers hooked into over 1,000 data banks throughout the world.
Wafa, thank you so much for the follow. So we're gonna say input stream map. You know what we really want to do is output stream. I mean, I guess it doesn't matter. It's like inputs, outputs. We're just gonna make an input stream map and then connect all the outputs to inputs, I guess. I don't know. So we'll connect this up to the processor that it's connected to. And I guess we don't even care about any of these loop indexes, so we'll just kill them all. I feel like it's quite possible that we're going to really want these node IDs and stuff like that. Like, sort of what we really want to store in our map is probably like a set of processor and the node that it's on or something like that. You know, to be perfectly honest, what we really want is actually to store all of these objects, right? We want the node ID, we want the flow, we want the processor, we want the input. Whatever. We can get there later. Okay, so we do this one first pass of setting up this map, and then I think we can do a second pass. I guess we have to sort of topo sort this stuff, right? Oh. Boo. Do I want to implement topo sort, or do I want to try to copy some other code that does this exact same thing from somewhere else? Yeah. So let's just take a look, quick look at something else here. We're gonna look at the thing that, let's look at this thing. Supports vectorized. I think has to do this, basically the same algorithm. It just does a whole lot more than just that. But yeah, you see it's got this map. This is very suspicious. Stream ID to input op. You're using the CRDB CLI, not bad at all. Cool, man, thanks. Well, we're trying to enhance it on this stream. So hopefully it'll become even better. Op-dag with meta source is the helper struct that stores an operator dag. Oh man. Definite F. Yeah, I don't know, guys. I think maybe this storm is like messing up the internet. Hopefully it'll stay like at least semi-stable. Yeah, there was some problem there. There was definitely some problem. I'm now gonna be one of those guys who complains, man, my internet's so bad, it's messing up my stream. Messing up my stream. Okay, so here's the thing though, right? We assembled this map from stream ID to opdag with meta sources. And then what do? We have to sort it at some point. It's definitely ISP, you guys. It's definitely ISP. It's definitely the ISP. Maybe this storm. I don't know. My personal brand. How do we do this topo sort? I don't really remember where it's implemented. I don't really remember where it's implemented, to be honest. Maybe we should just do it fresh, because that's kind of fun. That'll stretch my brain a little bit, because I don't really... Can do it with a queue. We can do it with a queue, maybe. I don't know. You hear Grand Pooh Bear once had an internet outage during some big event in Freetown and called his ISP about it because he thought his career was ruined? Oh. I don't know what to say about that, but that does sound scary. Yo, Yanzim, I am using the Gruvbox theme. Okay, that didn't work. I don't have it. Commands, add, theme. I use the Gruvbox theme for Goland. How about that? You gotta use those stream commands, right? So frequently asked questions. All right, so let's just I don't know. Let's just do this ourselves, huh? So how do you do topo sort again? You like add stuff to a queue, you process the things without any parents or something like that. So I think we'll say have a queue of processor specs or streams. What do we want our queue to be of exactly? We kind of want our queue to be of processors, and we want to start from the outside in, right? So that means the things with no outputs. Because the whole point, it's a stack. Project number 3 has to be with Go. How does it compare to VS Code and its Go integration? I don't use VS Code. I think people really like it, but I haven't really used it, so I can't really say myself. It's a stack. Okay. Okay. So it looks like we need to start with node. If we want to keep this representation, it's like for every node, for everything that doesn't have any outputs, we do stuff. Is it a stack? Why would it be a stack? I don't think it's a stack. I think it's like find everything without outputs, add it to the queue, and then for each of the things that are in the inputs of that also have no other inputs, add those to the queue or something like that, right? I don't know. Topo sort is usually done with the DFS. The thing is that in this case we have like a list, you know. I don't know. I'm gonna make a list of these. You know, we can actually do it inside of this loop too, I think. And I think that, well, no, we can't, because we need to make the full map for all input streams for all nodes. So we're gonna make a loop for node ID flow in range flows again. We can put our queue here, and the queue is gonna have processors. Let's just try it like that, I think. We'll say for I in range flow dot processors, if oh my god. People are going just buck wild with the copy pasta today, which I really love. Okay, so processor is equal to flow dot processors of I. Okay, so we're gonna if processor dot input or len in processor dot, we really want to know the output, right? So it's like if the length of the output is equal to 0, then we have a processor, a sort of, is it a root or is it it's a leaf processor with no further outputs. So add it to the queue of processors to print out about. So queue equals append queue processor. This is the wrong kind of processor. It's a processor spec. It's the thing that I want. Okay, so then once we're done with that, I guess I'm gonna, do I need to do a queue per node? I think I do. I think what I do down here is I say, I think I can immediately start with this tree printer thing. So I'll say tree printer dot child node d, node ID. I'll just call it, node child f. And then I think I do this queue loop. So I'll say for len queue is greater than 0. And this needs a length, I guess. This also wants to say queue is equal to queue of 0, just to clear it out. Can reuse that memory a little bit. So for while the queue has non-zero length, wow, I'm like struggling. Okay, so while the queue has non-zero length, what we do is we say, first we are going to print out the, well, first we want our processor. So we'll say processor is equal to queue of 0, queue is equal to queue of 1, like that. And then we're going to add a node for it, right? So we can say node dot, wait a minute, this doesn't make any sense because, do we want to just, maybe we don't want to do this with a queue at all. Maybe we do want to do this kind of with a weird kind of DFS using this map that we assembled. right? Like the alternative would be that like we get our processor, forget this queue thing for a second. We still want to find the things with 0 outputs, but then we sort of say for I in range processor dot output, and then we sort of like for every output recurse, something like that. Or then print its information and children. I guess it's really parents. It's like we're recursing back upwards from the leaf of the tree. Would that make sense? So like, for example, in this, yeah, I think that would make sense. I think that's actually a lot more straightforward. I think like there might be a sort of a downside of this approach if like there's some reason that we want to do more complicated processing. We sort of would want to have built a simpler graph representation, whatever. I'm just gonna do it like this for now though. So instead of this stuff, I think what we want to do is eagerly, like as soon as we get to this spot, as soon as we find a processor with no output, we're going to sort of like follow children. So like, I don't know, print output of processor, something like that. And I guess this thing is also gonna have to take this input stream map. Okay, I think this is actually gonna make some sense. So we'll make a function for this. And I guess it also needs the tree printer, right? So tree printer dot node. This stuff, just forget it. I think, I don't know. I'm still messing around a little bit. So I get my node, I pass the node into here. And then inside of, let's just comment this stuff out. I feel like we might potentially want to come back to it. I don't know. So what we're going to do is we're going to say TP. So node is equal to TP dot child of processor dot name or something. Is there a way to get a name for this thing? I can't really remember. What does a processor dot string do? It just prints out the entire proto. That's kind of no good. We sort of want to have, wait a minute, there's like a processor.core.
Data banks.
Yo, Fancy Yellow, thank you so much for the follow. This is annoying. Is there really no way to just get a quick string for the type of processor? I guess we can work on this later. When am I joining Team AMD? I don't know, man. It's like on my list of too many projects to do to build a computer, to be honest. I don't know. Yo, BeginBot, thank you so much for the follow. It's like one of those things I want to do. There's just a lot of things to do in life, you know, like building a computer is one of them. And it seems like a good thing to do, but I don't know when I'll get to it. Yo, Chapel, am I streaming Go Development regularly? Yes, I do stream every week, twice a week, once on Friday and once on Sunday. Follow me on Twitter. There's a schedule down below. Give me a follow on this thing too. But I only stream in Go, at least for now.
The computer's hooked into over 1,000 data banks throughout the world.
Yo, Cal's Fury, thank you so much for the follow. And Juan Pablo, oh my gosh, a follow chain. Thank you guys all for the follow, all three of you.
The computer's hooked into over 1,000 data banks throughout the world.
MD Layer, you spent 1,500 on an Aeron. Yo, I gotta tell you that I think that
data banks.
I got mine used. That's all I'm saying. I got mine used. I'm sorry. I hope you enjoy it. I hope it's new. Truth is, my used Aeron, its wheels are falling apart. So maybe that's something that you've got on me, right? The wheels are kind of like the rubber on them is like getting a little funky. I need to buy new casters, you know? So like there's some disadvantages. All right. So we print out our node, right? For I in range processor dot input. Yeah, databanks. That's exactly what he's saying. So we're gonna grab our input. We're gonna say processor dot input of I, right? We'll take the address of this thing. And then I guess for this guy, for each of the streams, we recurse. So that's pretty straightforward, I think. So for j in range input dot streams, stream ID is equal to input dot streams of j dot stream ID. You're still waiting on your ergo chair? You broke 3 chairs until you got your Aeron? Yeah, the Aeron's a good piece of kit, I wanna say. So we've got our stream ID, and what we need to do is now hook it up using the map that we made earlier to the processor that corresponds to it. So we'll say parent is equal to stream map of stream ID. Then we'll say print output of stream map. We recurse, whatever. Parent, and then node. I mean, I think like, right? Is that kind of it? I think the only thing is that this is going to be really ugly. And we kind of need to have a way of getting a pretty representation of the proto buff. What does the explain dissequel thing do for this, by the way? Because I feel like they've got exactly the same problem. Let me find out. Let's get rid of this stuff. Generate plan diagram. Generate diagram data. There's like some very similar code in a lot of places, you guys. I don't know what to say about that. Core.getValue. Diagram cell type. So this seems pretty useful. Probably don't want to just completely give this stuff up, to be honest. But it's all private, so I feel like I should just make it public. I'll just do that. So diagram cell type. There's no great reason for this all to be packaged private. Scissors, Go doesn't have generics is all you need to really save most of the time. Poof. Let me tell you, this stream has some history with that, my friend. It really does. We know. Okay, diagram cell type is an interface that allows, let's see, an interface for an object that has a summary, usable in an explain output. Yeah, so scissors, a lot of what we've done on the stream has been working around Go's lack of generics and lack of templating in general for this database that I work on, CockroachDB. You have to have, well, one way to make a database fast, a SQL database fast, is to have type-specific operators. And anytime you have anything type-specific and you want it to go fast, you kind of need generics or templating or something like that. So we work on that quite a bit. Today we're doing something bit of a different plan. We're working on an explain output thing. Yeah, we fight generics all the time. Yo, Yadrik, do me a favor, hit that exclamation point theme in the chat. Oh! All right. Yeah, it's GoLand. It's GoLand. Okay, so we've got the diagram cell type, and I think that each of these things is in fact a diagram cell type. So all we have to do in our new package to get a good string here, is to say title summary is equal to, then we can say processor.core.getValue like this, right? And I think this is part of the exec infra pb package at this point. Yo, this is pretty nice. So this gives me back a title and details. I think for now I'll just ignore the details. Well, no, let's print them out. We have the power since we're doing this tree, right? So here's what we're gonna say. The child is gonna have the name title like this. And then we're gonna say for I, or for S in range summary, we're gonna say node.add line S. And I really think it's just that simple, which could be pretty sweet if this just kind of works. But we'll see. We'll see. We don't need this node ID. This root, what's going on with this? I think I need to be going like this. I think we don't even need to define a new yes, we do. All right, so child node. Well, let's just say node. That's fine. So we make our node. We do this recursion. We can just get rid of all this commented out stuff since I really don't think it's necessary. And then at the very end, you know, why are we messing around with this IO writer thing? It's really pointless. Let's just return a string. So we'll return a string and an error. And down at the bottom, what we do is we just return TP, or root, I guess, dot string, and then nil. And apparently this thing can't have any errors, which is slightly shocking, but it's just that simple. So this is pretty sick. All right, so let's see. How are we gonna test this now? The truth is that I don't know if we have many just like test flows sitting around. I feel like most of the time when we have a set of flows, we've actually just constructed it from a query because it's just such a pain to build this map by hand, to be perfectly honest. Does Cockroach run as a system service on all 3 OS? I don't know quite what you mean like that. I guess you mean Linux, Mac, and Windows. It works on Linux, it works on Mac. Windows support is kind of beta right now. You can't really, you can use it for testing on Windows, but we don't recommend production use for Windows because, well, we just haven't really gotten around to productionizing it. You would write your test using queries as input instead of, yeah, I agree with you. I agree with you. It's just a matter of hooking it all up because constructing this even from, yeah, I mean, there's just quite a, there's quite a few steps to constructing these flows is what I'm trying to say. So here's what we can do though. I think what we want to probably do is make a variant of explain to SQL that just prints this stuff out. Or just have it print out. Or just have it print out no matter what. Oh, you know, we've got this explain options thing. How does this work? This might be actually a perfect use case for explain options. Explain options has a mode and flags. And there's flags and there's verbose, there's symvars, there's types. Okay, there's all this cool stuff. I think that what we should do is add a new flag, at least for testing purposes, and then use that to trigger the text output. Isn't it non-deterministic? Yeah, I do think that map iteration order is going to be a problem here. You're totally right. If the tests fail, you wouldn't know if it's the query parsing or planner or the latter parts. That's true, but we just have so much testing in this system for that stuff that it's kind of, I think it's going to be okay. I think you have a good point, but I'm not going to worry about that for now. I think I'm just going to make a new explain flag for this and see what that gets me. So I'll make an explain, well, this isn't going to last is the thing. That's the sort of nasty thing about this. It's not going to stay around for very long. Don't think. I don't know what to do. I'm sort of just stuck in indecision for literally no reason. I'm just gonna have it print out every time for now and then see where that gets me. Okay, so coming back down to when we don't have explain analyze going on. We make a diagram. We're also going to make this text output. So text output is equal to explain dot write distributed explain of flows. And this also has an error. If error is not equal to nil, we return error. Physical planning of query operators to flow processor locations. Yeah, I think that's sort of why in the logic tests we have those 5. We have like all of these tests that set up very concrete locations for the data so that it is deterministic. You had a flashback from work when you brought up allocating time and they didn't let you do testing. That is unfortunate. That is scary. I don't like it. I wouldn't work there either if I could help it. Of course, if you can't help it, then you got to live with it. All right, so we got our text output. Then what, right? Then what happens is that it looks like the output we set as, yeah, so what are the columns of this thing, huh? Right now, if you run explain dis-SQL, we get 2 columns and a hidden column, I think, an automatic, a URL. You know what I'll do? You know what I'll do is I'll just embed. I'll embed the output in the URL field just for now because I'm feeling like I want to hack this just to see what happens. So here's what I'm going to do. I'm going to say there's a diagram. There's also a text output. Ooh, I did think of a problem, which is that I think that this output needs to be in, it probably needs to be broken up by new line or something like that. Your buddy made Discord and became a billionaire? Dude, that's awesome. Unit testing or integration? Oh, you're talking to Lithium, I don't know. So we got the text output. It's just gonna be a string. We're just gonna say text output is equal to, right? Text output, like so. And then down below, what we do is we say if text output is not equal to empty string, we'll say, let's see, n.run.values is equal to tree.datums of nothing. If we have non-zero text output, I guess we can say lines is equal to strings.split text output with new line. Then we can say for line in range lines, n.run.values equals append. This is a hack, you guys. I don't know. I should really make another option for it, but like I don't know what the future is going to be, so I'm avoiding it for now. Tree dot. Wait a minute. Oh, this is annoying. The way this thing works is that it can only return a single node. No. I'll have to change this. Have to change this, no problem. Okay, so we're gonna append a new thing, tree.datums. We'll just put tree.dbool false. We'll put line, we'll put nothing, I guess. We need a tree.dbool string. Wait, not dbool, dstring of line. And I think we also need to like, okay, you guys, we were talking about generics, right? This is one reason why, wait, what? How does this work again? Make dstring? I forget how this works. Do I just go like this? Anyway, this is one terrible reason for why CockroachDB would prefer generics, if you will. I said that wrong. This thing, every time that you have a datum in the system, so that's like a column value or a row value or whatever, it has to be an interface in the old model because it has to implement a interface. And if you make a non-allocated thing, what am I saying? Everything has to implement this datum interface, right? And to do that, you have to do an allocation no matter what. So what we do is we make everything do the allocation up front so it doesn't have surprising behavior, but everything's super gross. This requires an allocation. Everything requires an allocation. Every single little buddy of data requires an allocation. It's the worst. That's why we went for this vectorized model when possible. Tree.empty string, is there a thing for that? No. New dstring. All right, so we've hacked in our output here. And at the very end, we'll, instead of doing equals, we'll say another append, equals append, tree.datums, n.run.values. Okay, we're close to getting some good output, you guys. I know you've been waiting for quite a little bit, but we're quite close. What is wrong with this? What the heck? There we go. I really messed up my indentation there. Okay, so then inside of next, what we need to do is we need to say like, we also need like an index or something, I guess, like cur idx is equal to, wait, what? Cur idx int. If done, we leave, and then we say if we say n.run. We're just like implementing a little iterator thing is what the way this whole thing works. If n.run.cur idx is greater than or equal to len of n.run.values, return false, nil, something like that. Yeah, exactly. Exactly, it would. Oh, you don't think it would? It wouldn't if we kept the row model. But we're not keeping the row model. The row model is gonna die. I'm gonna kill it. I'm trying to kill it little by little. N.run.idx. Okay. 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 I think we've done it, friends. Let us quit this whole thing. Make build short. Are you ready for my computer to get a little bit spinny? Because I think it's about to, unfortunately. You know, okay, actually, hold on. Let's not do this. We're gonna put it onto the remote node so we don't have to have the stream slow down. Hacks on hacks. Okay, so we'll make a new branch. We're gonna call this explain dist SQL text. Yo, TeckleDev01, thank you so much for the follow. Love the keyboard. What switch do you use? Hit that exclamation point keyboard, my friend, and you will find all about it. Git add 2, 3, 4. We're gonna call it explain dist SQL text. All right, we're gonna push this up. I have this little script. It's pretty nice. It starts up a cloud machine in Google Compute and SSHs to it. I didn't write the script, let's be honest. Work gave it to me. Thank you, Work. Thank you, CockroachDB, Cockroach Labs. But what's nice about this is that I can do a lot of compiling on it and it doesn't slow down my local computer. Of course, if I had that AMD Ryzen Epic box, I would not have this problem.
Everybody knows that relational databases don't scale because
yo, Lithium X4900, thank you so much for that tier 1 gift sub to Teckle. I really appreciate that. Teckle, welcome to the data bankers. Enjoy your emote. Kinesis Advantage 2 for life. All right, so we cd to this directory, we fetch. It's a bit of a struggle, but GitHub's a good web server. So let me check out explain dist SQL text. I'm gonna make build short, and then we can play around with what we've done here. The ancient, what is it called? LDB1 ancient? Large D1 ancient? Maybe I should change my, can I change my prefix to like something else or something? No, it can only be like a prefix of your actual username. Is that what it is? You guys know the reference? It's like, it's from the Ancient Aliens guy. Only partners can. But, like, you know this guy? Where is he? Where is he? I want one like this that says databases. I don't want it to have my face on it. That'd be the dream. All right, so we're almost done compiling. You gotta goof off when you're compiling, right? Oh boy. Okay, so we run cockroach demo, cockroach short, cockroach demo. Nodes equals 3. Actually, before we get crazy, to be honest, this probably isn't just it's just not gonna work at first. So let's show tables, explain dist SQL, select star from vehicles. Who's gonna bet it's gonna crash? Any bets? I think it's gonna crash. Okay, it crashed. Only the root can be stringified. This is why I should write tests, right? This is why we write tests. And we don't write giant integration tests that take forever to go back and forth. But what can I say? What can I say? I didn't write any tests. Come on, little buddy. Come on, little buddy. Okay, there we go. All right. All right. So what happened is that in dist.go, the problem is that we're printing out. We need to be printing out TP, not root. I want to make some tests for this, you guys. This is ridiculous. We've got to have some sample flows somewhere, right? I guarantee that somebody has hard coded a bunch of these things already, right? Flow diagram test. Like, I mean, come on. I should have used this. Let's actually. Why don't we just hijack these tests? To be honest, this is going to be a lot quicker. So what I'll do is at the end, I'm going to have another printer. I'm going to say explain dot. Ooh, but is this from the package that it's going to have a circular package import problem, isn't it? Total rip, and I think this probably won't work because we have private. Oh my god, it's the worst. It's quite the worst. I'm annoyed. Okay, here's what we're gonna do. We're gonna copy and paste this whole thing into another test because I'm kind of lazy. We can fix this later. So we're gonna make a new file called dist.go. This test rather. So we're gonna have func test. What is this thing called again? Write distributed explain test. Write distributed explain. T testing.t. Fix this later never. I hope not. Oran Barry. I hope I do fix this. I really hope I do fix this. Exec infra pv dot. I'm gonna need to have a lot of exec infra pv dots to add. That is irritating. Yo, this is so annoying. Is there a way to make this better? Like with a little macro? I guess it's just a few more to do. Later is the name of the black hole that we put things in. I think I'm guilty of that. Definitely I'm guilty of that on this stream. I think, to be honest, that the code that I read in this stream is like kind of trash. It's not great because I feel like it's hard to really think enough to make your code really well structured on stream. Doesn't mean I don't love it. I do love doing it on stream. I just don't think it's like the highest quality code I've ever written. Okay, almost done with this. Ridiculously dumb job. All right. Okay, we've got our sample flow. So now what we do is we call write distributed explain of flows. Error is not equal to nil. T dot fatal with error. You've never really seen Go. This seems like crossbreeding of C with functional programming. It's not really functional at all, although it does have inline functions, but I wouldn't say it's at all functional. It's very imperative, but it's kind of, you know, it's a language. It's like a systems programming language from Google. It's some memory safety features, so some concurrency features. It's pretty popular right now in the world of distributed systems at enterprises, I want to say. That's kind of the niche. So let's just print out the text right now, see what it looks like. How about that? Make test. I can just use go test. Go test. I've gotten addicted to using just go test instead of our make wrapper, because our make wrapper is just like, it does all sorts of unpredictable stuff that I never really want.
Computers hooked into over 1,000 data banks.
Yo, Oren, thank you so much for the follow. But maybe this is why we don't do it, right? Because when you run go test and you haven't gotten all those dependencies, things go wrong. So I'm going to run make. I do think that my computer is going to suffer from this. I do think it's going to have to compile a bunch of C. I do think I think it might give me a couple stutters on the stream, but we'll just have to see how that goes. Coworkers like obtuse make files. I just use Go tools. Yeah, the problem is just that, like in many circumstances, we do have to compile all of this C stuff, as you can see, and you can't really do that with just the Go tools. Yo, lunchbox sushi. Is there a way to handle error is equal to nil to have less boilerplate? I would say like not really. It's still a thing where you want to just do that everywhere. I think like in a couple of places in our code base, we actually do use like panic driven error handling because it's more convenient. But I wouldn't recommend that in general because it's a bit of a pain and it can lead you into trouble. I do think that in certain circumstances, it's quite convenient. But for the most part, yeah, you just kind of want to do the if error not equal to nil thing. You get used to it. You get used to it. Yeah, panics are, I mean, look, there's some cases where you really do want to use it. It takes a lot of stack rewinding to deal with errors sometimes. And if you want to make something that needs a lot of stack rewinding, unwinding, a lot of the times you just want to use panics. Burnt Sushi is a Rust person, right? Didn't they make RG ripgrep? I don't know why this is so slow to compile, huh? Oh, it's because I just run make test of everything. That is not what I want to be doing. Okay, let's just run this go test thing again now that I've gotten these dependencies installed and stuff like that. He did stuff with Go as well, but it was a while ago. Very smart dude. Yeah. Burnt Sushi. I do hear that that guy's the man. Okay, what's going wrong? Undefined flow spec. I guess I didn't quite finish all of those renames. Exec in for pv.flowspec is what I want. No? Why is it unhappy with this, huh? I feel like it shouldn't be. Let's try it again. Okay, so it worked, but I didn't get any output. It's because I didn't put -v. What main distributed algorithm does Cockroach use? It's Raft, if you've heard of that one. Okay, so we've got some stuff, but it didn't do anything good. But this is looking pretty encouraging. You know, we've got a little bit of a baby plan getting printed out. So let's, we could try to figure it out. What's the deal? It looks like we didn't even start a recursion, right? And I think probably the issue is that actually, yeah, okay, so we got here, right? We printed out the node, and then we never printed out any of the processors, and I'm guessing maybe it's because none of the processors had 0 outputs, which I think actually does make sense because I think that in the case of like the final processor in a flow, I think that it does have an output which is set to, how the heck does this work again? I don't really remember, honestly. I think it's this sync response thing. So like, yeah. I think what we really want to do is if len processor output is equal to 1 and processor, whoops, that's not an and symbol, and processor dot output dot of 0 it's just kind of a bit of a compound statement, honestly. Okay, so we'll just say if it's equal to 1, if len processor processor dot output dot streams is equal to 1 and let's capture this whole thing, right? Output dot type is equal to, no, it's output dot streams of 0 dot type is equal to whatever this thing is, stream endpoint spec sync response. So what this is just about is like, it's not just sync response though, is it? It's also like remote, I think. So yeah. sync response. What is it called? Oh Lord, what is this? Exec infra pb dot sync response. You know, it's even, I think I want to even make this a deeply nested thing. So stream type is equal to output dot streams of 0 dot type if stream type equals exec infra pb dot blah blah blah, or stream type is equal to exec infra pb dot. Yo, this is messed up, honestly. It's really like we want to check to see if whether all of the streams are remote or all of the streams are sync response. Yeah. Stiesel, what's up? Is this a gRPC interface somewhere, or do you use protobus for internal data structures? I went to a presentation where it's GRPC. That's disturbing, dude. I don't like that. There is a gRPC interface. So look, let me explain to you something, which is actually very, very cool. I think everybody will find this cool, maybe. So in this giant fat example, where is the fat example? Come back, fat example. Here's the giant fat example of a complicated plan that's distributed that we were looking at early in the stream. You can see that the node that's doing the planning, well, I'm telling you that the node that's doing the planning is this one that has this sync response. That's what we're talking about, by the way. When I've been saying sync response, that's the processor here at the end that's just going to be sending the results back to the user. And the way that we send the information about this like computation to the other nodes is via gRPC. So we make these flows like I've been talking about out of protobuf, and we ship them over to node 4, node 5. And that's how node 4, node 5, node 2, node 3, blah, 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 know how to set up table reader, sorter, table reader, merge joiner, and all the links between them and stuff like that. So it is gRPC, it is protobuf, and that's why we're messing with this stuff, because the whole point is that it's kind of like a distributed plan. I think it's just so cool. I think that this stuff is extremely cool. And I think it's quite fun to work on. But anyway, well said. Okay, so yeah. What we want to do is we want to say any local outputs is equal to true. And then what we're going to do is loop over each of the output streams for j in range output dot streams. Stream is equal to j output dot streams of j. And then I think what I'm going to say is if s dot type is equal to exec infra pb dot local. So this means that there isn't, it's not the end of the flow and it's not sending to a different node. Then this means that I do have local outputs and I can't start the recursion. It's not a leaf node. So I'll say any local outputs is equal to, I guess I want to do it the other way. So I want to start it assuming that there's no local outputs. And if I do see one, I set this thing to true, I break, and then down here, I can say, if not any local outputs, then I start my recursion. And I think that is how this will go down. Get rid of this queue stuff, which we don't need anymore. Okay, let's try that. Let's try that. Let's see what it does. Maybe it'll crash now. That would be progress, I want to say. Interface conversion.
Database.
Join reader spec is not diagram, so missing method summary. Yo, Kawa55, thank you so much for the follow. What's the deal with this though, huh? So line 78, I guess I did something wrong. It's saying join reader spec is not a diagram cell type, missing method summary. Oh, I think the issue with this is, this is annoying. I think I renamed this to be like capital S summary, but I didn't rename any of the users of it to be summary or something like that. Is that the issue? Yeah. That's the issue. Let's just rename them all, I guess. I think that's fine. So replace summary with summary. I think it's fine to replace this stuff. There's no reason to keep it package local at all, I don't think. Let's try again. Type assertion. Yeah, we do that all over the place. I guess just we didn't do it here. Why can't programming language just fuzzy match function calls, dude? Oh my God, that is epic. I don't know what that would give you, but it would be great. You know, you're totally right. We should do that. I think I will do that. I think the main reason that we didn't do it is because we're defining methods on proto-buffs, which is always like a bit of an awkward thing to do. And we can't do it right below the struct, which is sort of like the typical pattern, I want to say. Var underscore diagram cell type is equal to no op core spec. And we can do that once for all of these things if we really cared to. Okay. You want to do something cool? Oh no, F to the stream. F to the stream. Mini F. Mini F. We're gonna make these type assertions happen all magic. Yeah, sorry guys. I'm blaming my internet. Okay, we're gonna do a little bit of a magic find and replace here though. So we're gonna say func of dot star summary string. This needs to also be escaped. Okay, so here's what we're gonna do. We're gonna replace this whole thing with the same thing. Have a malformed, oh, I need to, we're gonna replace this whole thing with the same thing, but it's going to also have a type assertion above it. No, it's not for unused imports. It's to tell you that it's to assert that the type implements the interface, you know? This is gonna be so sick, you guys. I love doing stuff like this. So we're gonna put any comment. We're gonna capture this entire thing. You know, let's just capture this, well, yeah, we'll just capture this entire thing like this. This is like getting, the regex engine does not like this. Okay, I'm gonna undo this. I'm gonna do it this way. Did it just like crash? Okay. This is gonna be worth it, you guys. I swear it's gonna be worth it. All right, so we replaced this whole thing with 1, 2, and then above it, we're gonna put the type assertion. So we'll put, oh my God, no, it's not worth it. It's too complicated because some of them have variables and some of them don't. This is really where you want like the kind of like AST aware find replace stuff. That's, dude, that would be such a whole rabbit hole. I'm sure it exists. I'm sure like Go Please has some support for this in a sense, but it's like a little bit different from what I want to do here. All right, whatever. I give up. I don't really care. I don't really care. Right? Man, you've gotten me wanting to finish this. Okay, I'm just gonna do it later. I'm gonna do it later. Sorry for everybody. That was quite, wow. So this thing is just running. It probably is like infinite looping somewhere. So we've learned that our test is infinite looping. How about that for a problem? A fun problem to have. So why would it be implemented? Why would it be infinite looping, huh? The answer must be that we don't end our recursion at any point. And we need to end our recursion. Well, I thought it would automatically end the recursion if there were no inputs, you know? Oh, you know what we need to do? It's the same algorithm here. We need to only traverse the stream that are, we only need to traverse local streams. So we need to say, stream. We need to say if stream dot type is not equal to exec info pb dot local, then we just leave. Continue. Let's get out of here. Okay, let's try again. Maybe it won't infinite loop this time. We'll find out though. Still seems to be infinite looping, right, guys? Ha! Look at this fatty stack. Fatty stack. Why would it be doing this? Why would it be doing this, huh? We're getting the input we're looking at our inputs. We're getting the stream ID of the input stream. We traverse the stream ID to get the parent that's associated with it. Now, did I accidentally mess up and make this stream map contain children instead of parents? That would break this for sure. This is saying for every, yeah, I think this is just wrong, right? I think I need to be doing this in the opposite direction. So this needs to be output. No problem. No problem. We just had a complete fail of brain fart. It happens. Okay, let's try this again. More loops. More loops. Okay, we still have a problem, huh? We still have a problem. Who wants to use the debugger? I do. I do. Let's use the debugger. So we're gonna run this test. Why don't we just break right here before we get into anything? Well, we'll break here. So we're gonna hit that debug button. Gonna hit that debug button. I need like a noise for the stream, like burr, burr, we debugging. The only noise for my stream right now that I've got is this one. I love that. Yo, really, Frank, thank you so much for the follow. I appreciate it quite a lot. How's that storm treating everybody? It's still stormy where I'm at. Still stormy. It has not stopped.
Computers hooked
storming.
into over 1,000 data banks throughout the world.
Yo, Almamu, thank you so much for the follow, dude. We're staring at a blank screen because we're waiting for the IDE to compile our code so we can debug it.
Computers hooked into over 1,000 data banks throughout
Here we
the
go.
world.
Yo, Shima Shiro, thank you so much for the follow. Oh, did I just leak my whole password, you guys? I leaked like half of my password, but it's not an important password. Here's how we're gonna fix that. We're gonna hit this. I need to figure out like a password entering thing. Oh man, rip. I don't use that password for anything but my computer, so it should be fine, but that's embarrassing. GG. GG. Okay, so we're in our debugger. We're in our debugger. We print out our node for each of the processors. So let's, what processor are we looking at right now? That's the first question, right? got some outputs. The output is a pass-through router, whatever that means. It's got some streams. It's a local stream. It's got a target node ID. I guess I don't really care about any of this. But we do have local outputs, which means that we can't start printing output. So that's good.
Computers hooked into over 1,000 data banks.
Make an 8, thank you so much for the follow. I guess that was the only flow on that node. So now we've got another processor. And let's see. You leaked your system password on stream last weekend. Shit happens, man. Shit does happen. So here's another local stream. So you're gonna skip that one. Okay, so we made it to a processor that does not have any local outputs. So what outputs does it have? It's got some streams. It's got a single stream, and the output type is, what is this? It's a sync response. So this is the end. It's the end. It's the final output in this graph. So we're gonna start our recursion now in this print output thing. So we grab our title and summary. Our title is join reader. Does that make any sense? What is this? Hold on. Let's look at our, the test that we're running ultimately gives us a picture that is supposed to look like this URL. If I open this URL up, which is a long URL. If I open up this URL, what I get is this picture. So I've got 3 nodes, and I've got a join reader at the end. So that does make sense. A join reader is like a lookup join or a nested loop join, if you're familiar with that terminology from SQL. We've got 3 table readers. There's an ordered synchronizer. It's a response. That's very simple. This really we should make sure that this works. So it makes sense that we're starting a recursion from join reader. So let's continue our debugging and figure out what is happening next. So we print out our summary, which is just looking like primary at table. Very cool. Now for each of its inputs, what are its inputs according to this thing? There's 1 input, and it's got 3 streams, which makes sense because there's 3 nodes piping input into this processor. One's local, and the other one, wait a minute, endpoint spec local? How does that make any sense? How does that make any sense? I think I might have some confusion about how this graph is laid out, which might kind of explain some things. So let's just keep kind of recurring through this thing to see what happens. For each of the streams, if it's not local, we quit, but it is local. So we grab the stream ID. And what is the stream ID? What is the stream ID that we've grabbed? It's 0, which already seems suspicious. I think 0 might mean for local streams, both ends of the stream are part of a flow on this machine. There must be a corresponding endpoint with the same ID. For remote streams, this ID is used in the producer header when connecting to the other host. I art confused. I art quite confused. Hold on. Let me think about this for a quick second. Actually, you know, here's the thing. We actually have the entire graph, right? Because we assembled it by hand. So we should be able to look to see what is actually going on with this. I think the idea is that our join reader, where is that at? Where's that join reader at? Yo, Danilo Mello, thank you for the follow. Here's this join reader thing, right? Here's this join reader thing. This join reader thing has an output stream. And it's a sync response, so we can start from here. That makes sense. And it has a set of input streams with stream IDs 0, 1, and 2. And there should therefore be corresponding output streams with IDs 0, 1, and 2 in the same flow, right? There's stream ID 2. Not in the same flow, in different flows. There's stream ID 1, and there's stream ID 0. So I don't see, I'm confused what the problem is. What's the problem? Let's continue with our recursion and see what happens, I guess. Because I actually am slightly confused right now. So our parent is now what? Our parent is now... So you know, the 0th thing, whoops, come back. The 0th stream ID is supposed to correspond to this thing. So it's a table reader. It's supposed to be a table reader. And what is it? It's a join reader. So something is messed up, you guys. Something is deeply messed up. It's probably still with that algorithm that I changed for the better, that I guess I did not change for the better. Let's carefully think about this output stream map thing. How does this work? For each flow, for each processor, for each output, for each stream, we set the entry for the output stream ID to the processor that has the output streams. Does that not make sense? I feel like that should make sense. Like, I don't get that. You know, if we go back to here, what this is saying is that there's an entry in the map for 0 is supposed to map to this thing, right? Oh, I think I get it. I think I get it. Okay, the problem is that we need to not populate this map for this thing. That's the issue. I have like an extra entry for absolutely no reason because this API is, like, to be honest, slightly confusing. So what we need to do is we need to reject the output streams that are sync response. So if it's really just the same thing that we've been doing over and over. If the type is equal to exec infra.pb.sync response, then we continue. Don't worry, he has a Twitch plugin that will take your system password and replace it with asterisk if you type it in Twitch chat. No, but really he doesn't. Yes. What else was what else were you supposed to say but Hunter 2 at that moment? That's the only valid response. Little call and response game. Did that really not fix it? This is a bummer. I gotta say, this is a bummer. We gotta go back to the debugger. Here's another thing we could do. Why don't we just print out this whole output map, right? Are there other output stream types besides just the sync response ones that doesn't have, that has 0 for the stream ID? I think that would be the issue, right? So like, this one has no stream ID. Which other ones don't have stream IDs? Seems to be that really seems to be the only ones. So now I'm again confused. Perhaps we have like a different problem now. I think that this is annoying. I feel like the ultimate problem is that this graph is confusing. Let's run the debugger again. All right, let's look at our output stream map now before we continue. So what does 0 have? 0 should have that table reader, and now it does. So that's progress. 1 should have also. I think they should all have table readers basically. So 1 has the table reader, and 2 has 2 has the join reader. What's the deal with that? Why? How is that happening? How is that happening? That does not make any sense. Output I don't get this. How could that really be happening? Confusion. Confusion reigns. Am I missing something? Am I missing something? Is it something with... Is it something to do with aliasing, you guys? Oh my god. It's because... I think it's because of this. Because of this loop variable copy crap. This is a classic Go mistake. Okay, who's a Go newbie? A Go newbie, and it's not even a newbie mistake, right? Because I just made it, and I've been using Go for like 4 years. If you use this form of looping, where you ask for the value in a slice, and you take the address of this thing, that's gonna not do what you think it's gonna do, because it's gonna take the value of the thing on the stack, not the actual thing inside of the array. All right? So what happens is that you set this up, and then this is always the same. So everything gets kind of screwed up. Yeah, processor is equal to processor. So what I could also do, yeah, I guess, is that sort of like the like elegant way to do it? I usually do like I kind of just switch it out like this, and I say processor is equal to flow dot processors of I, and then take the address of this thing. Or I guess I didn't need to do that, but yeah, I don't know. Man, what a dumb problem. Dumb problem. Hey. Okay, so we're making a little bit of progress here. We have on node 3. Well, it's something, I mean, some things are looking slightly screwed up here. But I think in general, we're making a bit of progress. We know that on node 3, there's a join reader. The problem is that we're traversing across node boundaries, which is not really what we want to be doing. What we want to be doing is leaving the nodes that own a flow to be the ones that print out that part of the flow. So I think what we need to do is stop our recursion if we see a remote node boundary. The other thing we need to debug is why node 1 and node 2 don't have any things in them. So let's do that. I think the answer is probably again to do with these boundary conditions, which are just super confusing. If we look at our test, we can see that the output streams don't even have types, right? Like that's kind of the issue. The default type is local, and it really is supposed to be remote. So I think we really should set those, because I think the way, I just kind of think that like this is an invalid spec right now, which is yet another reason why we shouldn't be doing tests like this, but I just needed to do like a little, a little smoke test essentially. We'll do real tests with real data in a little bit. But I think ultimately this needs to be like type exec infra pb dot remote. Yo, what? I didn't know that this was like a thing. I didn't know that this was a thing, dude. How do you do that? You just put underscore TK? Channel point reward, dude? Not even the host could do it. Oh, man. I guess I have... What? Choose an emote to unlock? I don't get it. This is wild. You're like a Twitch master over here. Oh man, that is super funny. Okay, so what we need to just do is add this remote type to all of the output streams, and then I think like things should be groovy in a way, or they should be groovier. Not quite completely groovy, but they'll be on their way to grooviness, groovydom. So I think if we run this again, then hopefully what we'll see is on the node 1 and 2, we'll see the table readers, but we'll also see duplicate table readers, right? So we'll see node 3 has this, node 1 and 2 have these things. That's great. But what we want to do now is like kind of get rid of these things and replace them with nodes that explain that there's actually a link between node 1 and node 2 and node 3. And to be honest, what it also means is that the first thing that we print on a node that has an output that's going to a different node should actually not be the processor, but it should be some sort of like, you know, link that's saying like, this is going to be sent over the network, an outbox, something like that. So we'll do that. It's pretty funny. I'm into that as a concept. So here's what we're going to do next. We first want to prevent these things from traversing those remote links. So to do that, what we need to do, you know, I thought we did that. Again, I think this is just, it's just this the lack of, it's like the incorrect data problem. These also need to have type exec infopb.remote. I think that's gonna fix this issue up. Yeah. Run again. And hopefully we should see something a little bit more palatable. I'd say that this is, you know, it's approaching palatability. It's approaching palatability. Palatableness. The thing that this is also messed up though, right? Like this needs to be a child of join reader, not standalone. And the reason that it's standalone is that it thinks that it has no inputs, and it thinks that it has local outputs. Or something. What does it think? What's going wrong? Do all of our streams have the correct types now? That's kind of the question. You wonder if I could make a real-time backup system for CRDB that pretends to be a node, but it's just responsible for real-time backups, transaction log streaming. Yeah, we have this feature called CDC that's kind of used for this. It like you can point it at like a Kafka queue or something like that. It kind of does what you say. There's some plans for some more fancy stuff, but we've also got incremental backup. I don't know. There's like a couple of related concepts in the CRDB world. Let's look at these. Each of these streams do seem to have a type now, except for this guy, but I think this guy's special. So I think maybe it must be my logic that's wrong now. If I don't have local outputs, I print. If I don't have local outputs and I print. Is that right? Is that what I want? If I don't have local outputs, I should print. This thing does have local outputs. So like it shouldn't print. I don't know. It seems straightforward. This thing does not have local outputs. No, it does have local outputs, so I shouldn't print. Not. So what's the deal? How come this thing doesn't fire? What's the deal? Because I said it was remote. You guys, it's all about this incorrect test data. To everybody's point, we should not be constructing these graphs by hand because they're hard to do right. We're gonna do better. Okay. Now this is a little bit better, but still not great because again, this thing, this thing is supposed to have a link to the table reader and it doesn't. And again, that's because I screwed up the stream types. Okay, this is just a theme, you guys. I have to get this stuff all perfectly right or else none of it works. Right, because the point is that this input is from a local table reader. This output is for that local table reader, and they've got to both say local or else it won't really work. Okay, so this is now finally looking like something reasonably good. There's something a little funky going on with the ASCII art. Like this should be a line that goes all the way up. I don't know why that's not working. But fundamentally, this is good. And I think that the next step, what we want to do is we want to add those stream information bits, like I've been trying to kind of explain, so that you can see that this table reader is hooked up to this join reader as another input. So like we sort of want 2 more lines here that says, you know, remote table reader or something like that, like connection to node 2 or something like that. So let's see if we can program that. So how does it work? I think the first thing is that when we find our root, at this point we want to print out the type of output, if we're outputting to a remote node, we want to make it clear that something is linked to another part of the graph, something like that. If we're the sync response node, we want to show that this is the gateway and the results are streamed to the user from here. So I think what we'll say is if, I guess we'll say output is equal to processor dot output of 0. Yeah, so here it's kind of like, I guess we have to have 2 cases. Switch output dot, ooh, what if there's multiple streams? I kind of think what we want to do is like say for I in range, I guess it's again for j in range output dot streams. I guess we kind of want like a string builder in a sense. We want to print out a node. Yeah, it's kind of like what is this going to look like, right? It's either going to say, you know, sync response or whatever we want to call this, like send rows to user, or it's going to say route these rows to all of the streams. And I think, in fact, there's some information further that we can print out. So like, I think there's this thing called output.type. And this type is going to say whether it's a pass-through stream or a mirror stream or a hash stream or a range stream. And what these do is there are different ways of distributing the data. By hash is like hash the output and send it to a node in a consistent way. Like hash the output and mod it, and then use that as a way to distribute the rows to all of the outputs in your list of outputs. There's mirror, which is that you send everything to everybody. And then there's range, which is you try to figure out who the owning node is, in a sense. So if you have a bunch of rows and there's like a primary key that you know, and you know where that primary key lives, like where the leaseholder for the range that contains that primary key lives, you can send that row to that node. So you can do sort of like local processing at another stage besides just the stage at which you read the data in the first place. So I think what we want to do is print something based on this, like, so we'll say var sb strings.builder. Is there a way to stringify this? It looks like there's this, yeah. So sb.writeString output.type. Now here's another question. For this sync response thing, I guess it's a pass-through. Okay, so we'll say if output.type is not equal to exec info pb.passthrough, because we don't really care, I feel like in that case, to write pass-through, it's just sort of pointless. We'll just say sb.writeString output.type.string. And maybe we'll also write a parentheses. Now we'll do that later. Then what we do is for each of the output streams, we're gonna sb dot write string. I guess it's sort of like if j is not equal to 0, we'll say sb dot write string of comma, so that we can have a little ordered list here. I guess we probably also want a parentheses. We do, right? Kind of seems like we do. Or do we want to just make a list and then I'm undecided. I'm undecided. It's hard to do this visual design stuff. Okay, so whatever. We'll just do this. We'll put a comma, and if we for each stream, we're gonna probably want to like if output dot streams of j dot type is equal to, I guess there's really there's like a special case, which is this sync response thing. Why don't we handle that up here? If len of output dot streams of 0 dot type, sorry, len is output dot of len of output dot streams is equal to 0, and output dot streams of 0 dot type is equal to sync response. This is like a big special case because it's like the end of the line, you know. Sync response. We're gonna say sb dot. I mean, to be honest, in this case, we don't really need to even do anything with the right string, so we can put it up here. Special case, streaming rows to a user at this point. So we'll say node equals node dot child. I guess we could just say, yeah, what's the word for this? You know, it's like, you know, send to user, right? It's like end of the query. User. Output. Let's do output, whatever. Otherwise, this is our more complicated case. I don't think we even need that. We'll say sb.write string of parentheses. For each of the streams, we're going to write down our output node, right? That's kind of what we want, I think. No, we need more than just a node. We also need like, we sort of need it so that people can see. Like essentially over here, what I want to have is, it's like send to processor X, and then down here there's like a processor X, so you can see that this is connected to this or something like that. Plan? Are you asking what my plan is? Or are you asking about the plan of the SQL query? oh, maybe you're saying for output. Plan, yeah, I don't know. Plan, I don't know if that makes sense either. I'm not really sure. I'll ask, yeah. I feel like I want some other input on this, so I'll just leave it for output for now. So if it's the type of the stream. Oh, we already did the sync response case, right? So what we really want to do now is grab the target node ID. Really, we want to say like format.sprintf like node blah processor blah, something like that. Maybe it's just like node n processor n or something like that, and then end the parentheses. No, we don't want to end the parentheses yet. And then we'll put here, got to run your bosses at your house. Wow, that sounds intense. Good luck with that. Thanks so much for stopping by, Lithium, and thanks again for the gift sub. I'll catch you next time. Okay, so we'll put the output dot streams of j dot node ID. Let's actually capture output dot streams again. Stream dot stream ID? Yeah, so I guess it's like N1, S1, something like that. I guess this is a %D. Okay. Let's see what that gives us. Didn't give us anything for some reason. And that's because I didn't actually end up printing a node. So we have to say node is equal to node.child of sb.string, I guess. Try again. Okay, so this looks like a fail for some reason. And why would that be? Essentially, like, I'm a little bit confused. I thought that the stream here would have that sync response special case, you know? Why doesn't it? So if you look at our test data again, our output is passed through and we have one stream and it is a sync response stream. So why doesn't that work exactly? If length of output streams equals 1, not 0, there's my problem. Okay, let's try one more time. Okay, this is looking good. So we have our output. We know that this is what's getting sent to the user. I don't know if it looks good, but it's a step. We have our join reader. This is messed up. I need to figure out why this is messed up. We have our table reader. And then the next thing I guess is that we need to make an extra children for this join reader since it's got remote inputs. So that should be pretty straightforward too, I think. Also, yeah. Anybody who's just joining the stream, if you're confused about what we're doing, that would be totally reasonable because I think it's been a bit in the weeds for a bit. But what we're doing is we're trying to make a textual version of this visualization, which is a plan visualization for a distributed SQL query running on CockroachDB. We have this nice graphical output, which you might think is good enough, but truth be told, it gets pretty ugly when there are a lot of things going on in the plan, like this one. So my hope on this stream was that we were going to prototype a text version of this that might be, you know, to be honest, it might be overwhelming in its own way. So maybe this experiment won't really work, but I wanted to try it because I find this impossible to read, especially as it gets even bigger. So that's what we're working on. So the next step is going to be making sure that, right, this join reader's inputs are written down and you can see visually that they connect to these values. I don't know why this is saying N0. It really should say N1 and N2. I wonder if that's, again, a symptom of our test not having all of the right data. I kind of think it is. Only used for outgoing remote. Yeah, I mean, I think that is... that is sort of what we have here, right? It's like... Yeah, I think we need to populate this target node ID thing for each of our test flows, or else this won't really work properly. So target node ID in this case is going to be it's going to be 3, and then same for this guy. Let's try this again. And while that's going, we're going to start thinking about how to populate those inputs. So what we do over here is that we recurse if there are any local outputs. And I think the truth is that what we want to do, if there are not any local outputs, what we want to do what we want to do is what? Let me think. These are inputs, not outputs, right? So it's like once we get all the way down to the bottom, we see this table reader. Where are we looking through its inputs exactly? That's inside of print output. And this is now very confusing that this is called print output. Let's just call it like print plan. So for each of the streams, right, this is kind of the crux of it. If we don't see a local stream, why don't we just do a switch statement here? Switch, or I guess we can actually say if it's equal to remote, then have a special case, and then everything else is local. So if it's equal to remote, what we want to do is say, we still want to grab the parent. I mean, honestly, we can just stick this up here. Stick all this up here. If it's a remote thing, what we want to do is we want to print out a little bit of a special piece of information, which is that we have an input from somewhere else. So we're going to print out like essentially inbox, right? Like, I don't know, inbox is an overloaded word, but why don't we try it out? So we'll say node.child inbox, and then we can point it at, I guess we just want to print out this, right? Like the N3S1. So N S S D, and we'll put the, do we have our current node ID here? We don't, so we need to pass this into print plan. That's fine. Node ID. Okay, so we'll print out the node ID, and then we'll print out the stream dot, I guess it's just stream ID. No? And this needs to be a child F, so that we can get those interpolations all nice and happy. Okay, cool. Let us try it out. What does it look like? And we need to leave. Well, let's do a switch case here. Switch stream dot type case this thing. Case exec info pb dot local. That's when we do our recursion, like so. Okay, and then the other case, like the default is like it's really just like, you know, we can just panic or something like that. Unexpected. Well, let's just return an error. No, let's just panic. This is just like such an unexpected case that we don't really need to care about returning an error. Unexpected, like I'll just say invalid stream type, stream.type. Okay, let us try it again. See what it looks like now. What happened here? This needs to have a format.sprintf. Okay. This is looking good. I wouldn't say it's looking great. I mean, visually it kind of looks bad, but I think it's kind of like approaching the thing that I was thinking about at least. So I think the next step is probably to take us out of this test case and into the world of actual queries. So why don't we add this stuff? Well, you know what we could do is we could actually just run the exec builder tests, which I think live in exec builder. Explain. Where do they live? Hold on. Package SQL. So these exec builder tests, these are tests that it's in opt exec builder. Okay. So these are tests that are testing the transformation from the optimizer representation of a plan into this protobuf representation of a plan that I've been sort of working with. So those flows. And I think several of them actually have some test output that we use, or that's like related to that URL thing that I was looking at before. So for example, well, this one's actually kind of complicated. Forget this one. Let's look at, I guess what I could do is grep for, I do this exact grep a while ago, so we'll grep for explain this SQL. And maybe these would be some good examples. So this lookup join thing. So this is going to be a great example. So check this one out. This is a giant URL that encapsulates a big old lookup join plan that looks like this. I do think that this would be a good use case. So why don't we run these lookup join tests? So we're going to say make test package equals package SQL opt exact. You know, there's a shortcut for this. Make test opt logic files equals lookup join. I think this will run the test just for that particular file, and we can kind of see what it gets printed out. It's going to fail, and because the whole point is that we're changing the output to include that graph. So we'll see what it looks like, I guess. Hopefully it'll fail. I mean, truth is that I'm pretty sure I included this, didn't I? Like if I go to explain this SQL, which is, I'm pretty sure I folded it in, didn't I? Text output, then I print the text output. Yeah, I did this already. But why it's not doing anything? I kind of think that I probably screwed up. I don't know if you remember, I made a bunch of logic and never tested it inside of the explain to SQL node that checks to see whether, this looks right to me. Right. I think I think this actually needs to start out as like -1 or something like that. N dot run dot cur idx is equal to -1. I don't know. Yeah, there's some good progress being made. I do think that I can't tell whether this is just compiling slowly or the test started, and can never really tell. It's probably still compiling, you know, because the truth is that there we go. Okay, yeah, I was just impatient. Impatience, total impatience. Okay. Check it out. No, this is sick, dude. Look at this. It's actually completely unreadable. So I think so far this experiment is a failure because look, so here's the output that we were starting with, a nice pretty graph. And now here's the output that we ended up with, a giant list of trash that's completely impossible to read because there's too much of it. Well, is it a trash list? You know, I can't really tell. Like, it's saying what every node is doing.
Computers hooked into over 1,000 data banks throughout the world.
Yo, Edgar Mendoza, thank you so much for the follow. And it gives you these links, and theoretically you could traverse the links, right? You know, you see N1S6, and you can see that there's an N1S6 over here. But is it just too much information, you know? I want to say it's way too much information. I think that, like, I really want to figure out a way to make this useful. I think, okay, look, here's my other idea that I was sort of hoping to get to as well. Like, I do think that there's use for, like, this is good for something, but what we really would want to do, it's like, I don't know if you can notice, but like if you go over here to this graph, the truth is that and by the way, it's kind of cool. If you highlight one of these things, right? I'm hovering over this thing. You can see that it hovers it like highlights all the equivalent processors on each of the nodes. And the truth is that each of these equivalent processors, it's almost always completely identical, with the main instance of this not being identical being these table readers, which have spans that are different. And spans are like, you know, what subset of the data are we reading? The truth is that what I really would want to do is make it so that we only print out a single like flow from top to bottom and include in the metadata of that particular processor. So like instead of printing out, you know, 5 nodes and 5 join readers, I wouldn't write anything about nodes, and I would print out inside of the join reader information the fact that it's populated on 5 nodes, you know? That way, like, you could see the plan as sort of an ordinary hierarchy without having to worry about the distribution. But if you cared to see the distribution, you could look in the metadata for a particular processor and figure it out that way. So, you know, that's another option. I don't know exactly how I would do it. I think, like, basically, I would probably make it so that I would only print out information from this node. And I would need to have some equivalent, some notion of like equivalent processors, something like that. And then if for every processor equivalent group, there was a processor on the gateway node, I would only print that one. And in its metadata, I would print out the fact that it's populated on another node. And then for all the things that are only populated on remote nodes, I guess I would have to do something for those as well. I mean, I think, let's see. Is there some notion of equivalence already built into this thing? I thought that there was. You know, there's these processor IDs. There are these stage IDs. An optional identifier that can be used to correlate processors that are part of the same stage. Multiple joiners that are on a... Yeah, I mean, I think that this is kind of... We want the stage ID. Oh, it says it's useful for plan diagrams. Okay, so that's exactly relevant, I want to say. So it's sort of like... Sort of like we want to make a map from stage ID almost to other stuff, and then don't print stuff out if we've already seen the stage. Let me try that out. So while we're doing this pre-processing up here, First of all, I didn't even use these sorted flows. Okay, so let me quickly fix that. So the reason that this is irritating is that it's now using a map iteration order, which is not like a thing that is stable in Go. So we'll say for flow in range, sorted flows, and we'll say, I guess, flow and node. Flow is equal to flow and node dot flow. Node ID is equal to flow and node dot ID. Okay, so that's gonna fix that little small problem. Now the next thing I think I wanna do is make a stage map. So it's like stage map. Make a map from int to slice of processor spec. So over here, where does the stage live? Stage ID, it's right here. So I say stage map of stage ID is equal to processor. What is this thing? It's an int32. Okay, fine. Then I guess I append it, right? So equals append stage map of processor.stage ID, comma processor. Okay. So then, here's where it gets kind of interesting. I guess what we really do is that we get rid of these stopper areas where we say, you know, stop traversing. And we always traverse, but we don't print anything if we see a stage that we've already printed, right? So I guess in our stage map, we sort of want like a bit. We want a bit that says, yeah, so this stage map, we want to not just store processor, we want to actually have a struct. So we'll say type stage info struct. It'll have a slice of exec info.pb.processors. It'll have a stage ID. Well, we don't really need that. We'll just have a scene bit. So then over here, what we need to actually do is make this a stage info. Info is equal to stage map of blah. Info.processors is equal to append info.processors processor. Stage map of processor.stage ID is equal to info. Okay. You know, I always get a little bit confused. Like when you have a map of stuff, it's like a little bit more convenient to honestly have like a pointer typed in there, because then you don't have to like pull things out and put them back in. So I think I'll do that here. So I'll say I'll say info okay is equal to stage map. Well, I could just go like this. If info is equal to nil, info is equal to stage info, and then I reinsert it back in. All right. What's wrong with this? Oh. Variable shadowing. Okay, cool. Okay, cool. Now, I really sort of want to, should I like preserve this somehow? And then have like a different mode just so I don't have to like, why don't I make a commit? That's one way to do it. So we'll say git add 2, 3, 4, 5. Work in progress. We'll call it like explain, or we'll say like dist explain without stage collapse or something. Epic Ranger 65R, am I hacking, comma programming? I'm speechless. I'm hacking and I'm programming. I'm not doing like that kind of hacking though. I know what you're thinking. I'm not doing that kind of hacking. I'm programming. All right. So we've made our commit. So now we can just go ahead and hack this thing apart if we feel like it. So what we'll do is that do we always set stage ID? I mean, that could be a fatal flaw of this whole approach if we don't always set stage ID, right? I don't know. Maybe we do, maybe we don't. Hopefully we do. I just hope we do. If we don't, that sort of screws this whole idea, but. All right. So we loop through our processors. How do I, let's see. We still want this code because this is the code that's finding the root of the graph. F to stream, dude. Frustration, huh? Frustrating. Well, I don't know. I think it's green now, maybe. Whatever. Maybe refresh. Maybe this is going to be a kind of dead experiment for today. We'll see. Okay, it looks like things are stable again. There is a blip, but maybe things are stable. Maybe. We'll see. We'll see. Okay, cool. So we're still gonna keep this thing where we find the roots of the graph and start traversing there. Ooh, I don't know. I hope it's gonna stay. I hope it's gonna stay. My OBS is flashing red, yellow, and green at me in a really scary looking way. So I don't feel that confident that this is really working anymore. Why? Optimum Online. Optimum Online, I hate you. All right. All right. Okay. Keep the thing where we find the roots. Then what we do is that we keep this code maybe, I don't know, inside a print plan, inside of the recursion. This is kind of where the thing is going to have to change. Inside the recursion, what we do, inside the recursion, we also need to pass in this new information, right? We need to pass in our stage map from int32 to exec info pb dot, no, sorry, to stage info. And we need to propagate that in the recursion. And then what we do is that we just say if, you know, if processor.stage ID, if stage map of processor.stage ID dot scene, then we leave. Nice and simple. And then we say stage map dot processor dot stage ID dot scene is equal to true. Okay, so now what we do is I think all we need to do is kind of like improve our summary. So it's like first of all, we want to grab this, right? We want to say stage, we want to call this info. Maybe we call it stage info. What we want to do when we print out our summary here, we also want to say node dot add line we're doing the tree output of the query plan. Yeah, exactly. So we already have, I mean, to be totally clear, we've already got many explain variants. If I say explain, let's see, create table, a int, explain select star from a where a is greater than 3. We already have like a tree output kind of looking thing here, and then we could make it even better. We could put a count star. The thing that we don't have is a way to see this when the query is distributed. So that's like what this thing is about. Trying to include the distribution information in this explain output. So what we do now is that for each of the stages now, we can print out some more information, right? We can say like for I in range stage info dot processors. I guess we want to say like, if len stage info dot processors is greater than 1, then we print out extra information, right? So we say like node dot add line nodes. Ooh, do we need to put the nodes in here too? We probably do, right? So when we append to these processors, we also want to append to the nodes. We'll say info.nodes is equal to append info.nodes info.nodes, comma, node ID, which I guess we do need now again. Node ID, having problems typing. Okay, cool. So then down here, we'll say stage info dot nodes. We need to add line F. There's no such thing. That's annoying. I think actually what we need to do here is this needs to be a child F. That's why we're getting those weird lines. I think what we need to do is like, how do we say? So child string is equal to sb dot, or strings dot builder, var child string strings dot builder, let's say. So we'll say child string dot write string title, write string new line, and then for each of the things here, we'll say child string dot add line. Is this child string? Is that really what we should call it? Like, you know, yeah, whatever, child string. Okay, so we'll say child string dot write string nodes of this. And I guess we need a format.sprintf. And then for each line in summary, we do the same thing, child string dot write string of s. Right? And I guess we also need a new line. I wish that the string builder had like an easy way of doing a new line, but I feel like it doesn't. And then we say tp.child of child string, and then I think that's gonna be a bit better. So yeah. Okay, so we've got, essentially what this is saying is that for a stage that's got multiple nodes in it, we print out all of the nodes involved in the stage. And then I guess, let's see, well, why don't we check out what this is gonna look like first of all. Why don't we check out what this is gonna look like? I guess I could just run our original test. Whoops, what happened here? Not enough arguments to print plan. Need to pass the stage map. This is looking interesting. We forgot to put a new line, so it's looking nasty. Why don't we just collapse these? F format.sprintf sn with the title. And likewise for this one, we need a new line. All right, try again. Okay, this does not look quite right. Yo, Tom Tucka, have I ever used Swagger Code Gen to generate a Go API client? I have not used Swagger in Go. I haven't, but I know a few of my colleagues have used it. It seems cool. Are you using that? Have you tried it out? What do you think of it?
I'm not going.
So something is a little bit funky, which is that like, oh, it's because we're still not recursing through the inbox things, I think. We want to get rid of that. Isn't there like a fall through thing? Go circle CI. This looks cool. I'll open it up on stream. This describes the resources that make up the Circle CI API v2. Go library for accessing the Circle CI. Dude, this is cool. So you're saying that this is a Go API for Circle that you didn't have to write yourself because of Swagger. So the way this works is that you describe in a YAML file all of the API methods for Circle. This is cool, dude. It's kind of annoying that Circle doesn't you know, provide that themselves, but if only they did, huh? They provide an open API spec, which is easy to convert. That's awesome. I haven't seen open API, but that seems pretty neat. So I'm actually a little confused here. Like, what if we just get rid of this whole switch case and always recurse? I don't know why that's always hard for me to say. So something's going a little bit wrong, and I'm confused about it, right? It's like the recursion sort of seems to stop at join reader for some reason. Is it because of this stage info stuff? Is the stage info for this stuff populated properly? Stage 1, stage 1, stage 1, stage 2. So that all seems like fine. I don't quite understand why it's not recursing past. Oh, it's because we do it in the first node. Oh, I see. Oh, this is kind of interesting, actually. So what we need to do is actually find the gateway node, right? And only do it on that one. So instead of recursing through each of the flows, we actually need to have an extra piece of information, which is what the gateway node is, right? So do we have the gateway node here? I feel like we should, right? Somewhere. Fizzplan dot gateway node ID. Okay, we do have it. So we'll pass that in as well. We'll pass in the fizzplan dot gateway node ID. And we'll add a node ID to this thing. Gateway node ID roach pb dot node ID. Okay, so then down here, instead of saying, first of all, we don't even need to care about this sorted flow stuff anymore. Just get rid of that altogether. And then we'll say flow is equal to flows of gateway node ID. And we get rid of this whole loop. Nicely brings down our indentation, which is getting a bit out of control. And we don't have to put this node ID stuff. We don't need it at all. Yo, MD Layer, grocery store time. Thank you so much for hanging out. Appreciate it. Have a good rest of your weekend as well. I hope to see you on your stream. Have a good one, man. Thanks for stopping by. So I think we, instead of redefining this stuff as node too, we can just probably keep now we'll just say node is equal to root. How about that? All right. Let's try again. I think now, whoops, what happened here? Right, we forgot to update our test to include the gateway node as a parameter. So here we need to include the gateway node, which happens to be number 3, I think. Cool. Okay, this is you know, it's progress, I think. There's still something a little bit weird going on with these lines that I don't quite like. I don't know why this isn't like drawing through properly. Oh, you know, maybe it's because when I initialize this tree printer thing, maybe I should stop. Maybe I should sort of just use its defaults. Tree printer.new. How about that? Try again. Maybe I've messed with the default so much that it... Oh, no. Now it's just fat, but it's still really ugly. Why is that? I don't understand. I don't understand why that would be. Multi-line strings are supported with appropriate indentation, it says. But how come it gets all ugly like this, you know? Maybe that's like a bug report for the tree printer program, and I don't have to worry about it too much here. But yeah, overall, let's see. So let's actually run this again on our bigger test case. So this lookup join thing to see what it looks like now. So I'm hoping that it actually might possibly be better than it was before. It's gonna have the node. Essentially what we've just done is we've augmented the simple disk-SQL plan with the node IDs of each stage. And I guess that's like almost enough. Like the things that are sort of missing is like trying to, if you wanna try to figure out like the links between each of the output stages and the types of ways that we're shuffling nodes across the network, that's not quite in here yet. So I guess what we sort of need to do is insert a node that says that I'm shuffling data across the network. And I think if we had that, then it's actually quite possible that it could be good looking. So what does it have? Yeah, you know, like this is kind of neat, right? It's like got the table reader. We know that it's on all of the nodes. What we don't have is how the table reader is shuffling its data to the join reader. And if you look at the plan, you can see what it's doing is it's just sending them straight, you know, with no kind of shuffle at all. But we don't have that information, so we sort of have to add it. And it's also not clear based on this diagram that, like, you know, these connections are local in a sense. Like I would sort of need to say that, somehow say like, hey, the table reader in this stage is connected to its friend join reader on the same node. And there's no network at all until the output of the join reader. Like this is sort of what we need to fix, right? We need to put like send to gateway node when appropriate. Yeah, I think, all right, I'm gonna be right back, you guys. Just hold on a second. Just need 2 minutes. Yo, I'm back. I am back, and maybe my internet is doing a bit better. Got that green light on OBS, which is always what you want to see. Cool. So here's what I was saying. What I was saying is that we need to print out something here to show that we're sending data across the network in some cases, basically. So I guess what that's going to look like is that if the input streams are remote, we have to print something else, right? It's like, if input dot type, well, is that right? Input dot, sort of like if we have multiple streams, we want to print something out. Yeah, that's what we want. So it's like if input dot streams is greater than 1, we're gonna do sort of like node is equal to tp dot child of, let's see, and do we have a way to print out the name of this type already? I feel like we probably do from that other file, right? Where would that be? Flow diagram, maybe? I feel like there's got to be somewhere where we print out like, hey, this thing is called you know, ordered or unordered or whatever, right? I don't see it. Unordered. Oh, interesting. There actually is a summary implementation for input sync spec. That's interesting. So when do we use that? That actually doesn't make that much sense to me. But it's fascinating. We need explicit synchronizers if we have multiple inputs or if the one input has multiple input streams. It's like, this is basically what we want, right? It's kind of funny, like I just wonder whether we should be able to share a bunch of this code, you know? But, well, I don't think it's really gonna be that easy. God, the internet is just not working so well, huh? It's frustrating. I might just end the stream, honestly, because this is driving me crazy. Just seeing that red light blinking is kind of making me feel like, what are you guys even seeing, you know? So, you know, I think I'm just gonna end stream early tonight, to be honest. But I think we've been making some good progress. I'm gonna tweet about this because I think that we've actually come quite a long way, and I'm excited about it. So I'm just gonna find somebody to raid while we have the good internet, because, you know, there's really no point to having like a stream where it's not working. But thank you guys so much for hanging out. I'm gonna do another stream on Sunday. So if you are around on Sunday, please check me out. Yo, I'm gonna actually raid this person, Gene QA Soar, who's a programming language researcher. Gene QA Soar. So say hello to her. I think that she's doing an interview potentially right now about programming languages and stuff, and I sort of want to, yeah, check out what she's up to. We've talked a little bit before on Twitter about this stuff, but in any case, you guys have a great weekend. I'm going to do another stream on Sunday. Hopefully, the internet will be a bit better then. So check me out if you're there. And in the meantime,
Computers hooked into over
please
1,000 data
say
banks
hi
throughout the world.
to Gene. And Lost Algorithm, thanks for the follow. And I'll see you guys next time.
We're going to experiment with a discussion format where we say things and then you guys say things back to us in the stream. Oh no, there's a, what's a raid? Large, oh, hey. There's a...
Oh, I think that just means that there's like 16 other people coming in with this person. I don't know.
Interesting.
I'm totally a Twitch noob.
Yeah.
Like I play games, but I don't do any streaming. I don't really watch.
We're getting 16 new viewers.
Nice.
Or something. I don't know. I think that's what's happening. Thanks, guys. Thanks.
Yeah.
So we have some stuff prepared. I've actually never led a discussion where, you know, it's two people discussing and then other people discussing in the chat. But